When selecting a model, what points of view do we consider? Generally, we consider 2 points of view. The first one is the probabilistic point of view. In the probabilistic point of view, the model describes a data-generating process using probabilities. It focuses on understanding how the data might have been produced and can quantify uncertainty in predictions. The optimization point of view, in this point of view, we treat the model as a function with parameters that we need to optimize. We aim to maximize some performance measure, so either accuracy or likelihood or utility. And so these two different points of view allow us to understand data in a couple of different ways. So just to recap very briefly, the probabilistic point of view is about understanding the process. The optimization point of view is about finding the best parameters. So in the probabilistic view, the goal of the model is to model the underlying data generating process. Here we want to treat data as being generated according to some probability distribution. The model defines the likelihood of observing certain data values given its parameters. And of course, this point of view has some advantages. We can quantify uncertainty in our predictions, which is really, really nice. Often it's good to have a prediction and then some sort of numerical value that tells us how certain we are or how much we believe this particular prediction. It makes it easier to reason about missing data or noisy observations. We can have data being equal to something with a little bit of plus or minus. And it provides a natural framework for using Bayesian statistics and inference. And so this allows us to adjust our guesses based on additional information. Some examples of the probabilistic point of view are Gaussian distributions for continuous data, logistic regression for binary outcomes, and hidden Markov models for sequential data. When you talk about the probabilistic point of view, you want to imagine the model more of as a story. And you want to ask, what is the probability that the data was created using this particular story, given the assumptions that we've made are true? The counterpoint of view, the optimization view, tries to find the best model parameters that maximize the performance on the given data. The approach is to define a utility function or a loss function that has some sort of measure of model performance. Training becomes an optimization problem. We either want to maximize some sort of utility or minimize some sort of loss. Now, the advantages to the optimization point of view is that it's focused directly on performance rather than assumptions about data generation. It works well when the predictive accuracy is more important than the interpretability. That is, we want the answer rather than why the answer is the way it is. And finally, it's flexible and applicable to a wide range of models. Some examples include linear regression, where we try to minimize the least squares error, neural networks, where we train them using a process called gradient descent, and support vector machines, where we maximize the margin. Intuitively, you want to imagine you're climbing a hill and you want to reach the highest point. You don't really care how you get there. You just want to get to the top. The top, in this example, is the best performing model, according to whatever your chosen metric is. And so those are the two points of view that we want to consider when we select a model.